So calculating an equilibrium constant from equilibrium composition. So by now we should be comfortable with writing equilibrium constant expression, especially for homogeneous equilibria like this one. So we can see that all the reactants and products are all in the same state of matter. In this case, they're all gaseous. They could also all be aqueous. That would be fine. So remember, for heterogeneous equilibria, if anything is in the solid or liquid state, we do not include it in the equilibrium constant expression. So for any generic equilibrium reaction, you can write equilibrium constant expression of the form the concentration of each product raised to the power of its stoichiometric coefficient divided by the concentration of each reactant, each raised to the power of its stoichiometric coefficient from the balanced chemical equation. So that's a general form that any equilibrium constant expression will take, leaving out anything that's in the solid or the liquid state. Okay, so if we actually have those equilibrium concentrations, we should be able to substitute them into the equilibrium constant expression. So let's look at our particular equation. We have the reaction between hydrogen and chlorine to form hydrochloric acid. So first of all, we should write our equilibrium constant expression. So the product, hydrochloric acid, will go on top, and that will be raised to the power of 2 because its stoichiometric coefficient is 2 in the balanced chemical equation. And then divide that by the concentration of the reactants. So that will be our H2 and our Cl2, and each of those is just going to be to the power of 1 because there's only one of them in the balanced equation. So then if we actually have those values, we can just substitute in those equilibrium values. Be careful if you do have any powers in there, okay? Don't leave them out when you're actually substituting the numbers. So we were given the concentration of hydrochloric acid is 0.5, and of course that will be squared. Let's see if I can make this look prettier. So 0.5 squared. Be careful with parentheses on calculators, etc. You'll probably need to use a few to make it understand what you want it to do. Then concentration of H2 was 1.5, and the concentration of chlorine was 1.6. We don't have to worry about units to all intents and purposes. Equilibrium constants are they have 0 for units, so they're unitless. So that comes out as 0.10416, blah, 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 blah. We're asked for 2 sig figs, so that'll do. Okay, so whatever the equilibrium values are, you can substitute them in. It will work if you have written Kp, the equilibrium constant, in terms of partial pressures, and then you can substitute in partial pressures. Just remember that you're calculating Kp, not Kc, if that is the case. And that's pretty much all there is to it.